This lesson is all about one of the most shocking events to have affected the UK in the last 100 years. The largest peacetime disaster that Britain suffered. This is the failure of the coal waste tip at Aberfan in 1966. With this lesson, I want to focus on the geology of this disaster. Rather than the politics or the sociology of it, I want us to focus on the geological reasons why this tip failed so catastrophically. For this, you'll need the handout with some data on the Aberfan. Okay, let's go. If we just look at the bare bones, sort of the facts and figures of the disaster, I think they're shocking enough. 9:15 in the morning on the Friday before the October half term in 1966, a tip of loose waste rock from the Merthyr Vale colliery failed. It flowed downhill up to 9 metres high at about 34 kilometres an hour and ploughed into the village of Aberfan, and in particular hit the Pantglas Primary School. This disaster killed 144 people, 116 of which were primary school children. A generation of children in the village were killed in this one morning. Let's have a look at the geology. This is a map of the site. You can see there was a series of waste tips deposited high on the valley side. And the underlying geology here is one of sandstone and shale, fairly typical of a coal field. We also have deposits of glacial till in the bottom of the valley. Notice that the failure here is at a junction of these materials. This is a cross-section through the tip and the underlying geology. With some questions to go with it. The questions are also included on an accompanying PDF. Having worked through those, I then want you to think about the factors that were responsible for this. There are quite a few to pick from here. See if you can pick the two that you think had the greatest responsibility for this disaster. Now, I said at the start of this that we were going to focus on the geology. It's fairly clear that it's not just a geological disaster. There's certainly human influence on this. So the last part of this question is more about what should have been done. How could the risk from this mass movement actually have been reduced before the failure of it? What should have been done? Okay, have a go at those questions now. See what you can come up with. Okay then, let's have a look at some answers. First question asks you to look for the location of a spring. Now the spring is located here. You can see where the water table reaches the original ground surface. That's where we're going to find the spring. Crucially here, the deposition of the glacial till forced that water to the surface. Glacial till is impermeable, acts as a cap on that aquifer, so the water table in that aquifer is going to rise until the point where it can come out of the rock. Number 7 tip, though, had been built on top of that spring. The failure surface then would have looked something like this. That water is going to undermine the base of the tip, and we end up with a rotational failure as a result. So the two geological factors that may have been responsible for this, take your pick. We have loading of the slope, the groundwater, rainfall. The end of October 1966 had been a period of several weeks of very heavy rainfall. The lithology here that would have had an effect, the angle of slope, not the dip of the beds, the actual angle of the surface slope, and maybe vibration. If we're trying to select the two that have the most effect, I think the groundwater must be key. This failure occurred because the loose waste material was liquefied. Groundwater coming out under pressure into that loose waste material reduced its cohesive strength. We then have something else adding to that. The rainfall would have caused the level of groundwater, the water table, to rise, made the spring more discharge at the spring. But the lithology also has an effect, creating that spring. The steep angle of the waste slope would also have had an effect. To explain the role then each of these would have had, groundwater is increasing pore water pressure. It's reducing the friction between the clasts within that waste material, causing it to liquefy, causing it to lose its strength. The lithology, we have a permeable sandstone allowing water to flow through it, but that water then was being forced out the ground at a higher level perhaps than otherwise would have been the case because of the impermeable till. It does beg the question, what should have been done? There's a number of things that could have occurred. Monitoring the waste tip far more carefully than was done. It's quite shocking to learn that people knew the tip was moving before it failed, but nothing really was done. Monitoring the groundwater pressure to know what was actually happening to that groundwater. Mapping the site carefully in advance. The fact there was a spring there wasn't unknown, it wasn't a surprise, but there was no concerted effort, no systematic effort to map those springs and to design the tips in light of that. The tips were just dumps of material. And then things that could have been done to actually stabilise those slopes. Drainage of the slope, being able to get water out of the hillside without it getting into that waste material, diverting the water, for example. trying to have something that, well, slowing down a flow of that size is probably almost impossible. Really, the key to it would have been to deal with that water. This, for me, is one of the hardest lessons I teach in A-level geology. The toll of failure to understand the geology is shocking. It serves perhaps as a warning of what happens when geological factors aren't carefully enough considered. 1966 was a very different world, particularly in terms of corporate responsibility, in terms of health and safety. But the geological factors could have been known. There was no new technology that we'd employ now that wasn't available then. But by being aware of these issues, by doing something about it in advance, anticipating the hazards that were caused, could have prevented disaster on such a scale. It shows the importance of understanding geohazards. It shows the importance of remediation or careful planning if you're extracting waste material to be able to prevent this. The waste tips in the valleys were stabilised, unfortunately, in the aftermath of this rather than in advance of it. Shockingly, the money raised for the families was used for that remodelling of the waste tips. We're seeing, in response to climate change, more concern about those remodelled tips. Tips that we thought in the past were stable are now threatened by more intense rainfall that seems to be a consequence of climatic changes. Now, to see a bit more about this, the TV series The Crown, who filmed an episode based on Aberfan, produced a documentary to give the story behind it. It's well worth a look. We should, though, bear in mind the human cost of failing to take into account potential problems. And as geologists, we shouldn't forget the consequences of failing to do our job well. I'll see you next time.